So there's our x and y components. And again, we want to figure out now how long is this projectile in the air. Okay? And so what else do we need? So remember, to figure out how long something's in the air, we consider only the y motion. Okay? And remember, our best equation for dealing with figuring out time in the y direction is this one. Y final equals y initial plus vy initial time minus 1/2 g time squared. Okay? Now, we know what y final is. We know what y initial is. At least we know what the difference is between those two. It's 12 meters. So let's bring y initial over to this other side. Let's subtract it from both sides. And when we do that, we have this. Okay? So what is y final minus y initial? Well, it's not 12, it's minus 12, because our final position is below the initial position. So in other words, if this is a height of 0, this is a height of 12, 0 minus 12 is minus 12. So over here then we have minus 12, and that equals Vy initial times time. Vy initial is negative 1.75 times time. And then we have minus 1/2 gt squared. 1/2, g is 9.8, remember, times time squared. Okay, this again is a quadratic equation, and we're going to want to use the quadratic formula. So let's get it into a useful form for the quadratic formula. So after a little bit of algebra, 1/2 times 9.8, add that to both sides, you get 4.9. So 9.8 divided by 2 is 4.9 t squared. We want to bring this over to this side as well. So we get plus 1.75 times time minus 12 equals 0. Okay? Okay, so using the quadratic formula then, t is, remember, it's negative b plus or minus square root of blah, blah, blah over 2a. So look up what the quadratic equation is. So this is b, so it would be negative 1.75 plus or minus the square root of b squared, 1.75 squared, minus 4 times a, which is 4.9, times c, which is minus 12. So 4 times 4.9 times minus 12. Okay, and that's all divided by 2 times a, which is 4.9. So 2 times 4.9. Okay? So we do we have then negative 1.75 plus or minus. So when you do this calculation here, 1.75 squared minus this whole thing here, you get, and take the square root, this whole thing here is 15.44. And 2 times 4.9 is 9.8. Okay? And so remember, we get to a point here where we have two solutions, one corresponding to plus, one corresponding to minus. And we want to pick the one that makes physical sense. So the minus sign doesn't make physical sense. We would get a negative time. So we want to drop the minus solution and just use the plus one. So negative 1.75 plus 15.44 divided by 9.88 is 1.397 seconds. Okay, so we calculated the time now, and now we just need to know how far does this projectile go. So let's erase this stuff here. keep the time, so let's go ahead and write that up here now. The time that the mouse is in the air is 1.397 seconds. Okay, so now that we know how long the mouse is in the air, now we can calculate how far it goes. And this is where we just use the x component. We can just, once we know the time, we can calculate how far it goes by just considering the x motion. And so our equation describing x motion then, how far it goes, would be this equation, x initial plus vx initial times time. Okay? And so the distance that mouse travels then would be our final x position minus the initial x position. And that equals vx times time. So what we just did there is we subtract this from both sides, so we get that minus that, and this becomes an equal there. Okay? Now vx initial is 3.031. Time is 1.397 seconds. Okay? We multiply those two together, and what we get is that the distance, x final minus x initial, the distance, the horizontal distance where the mouse ends up is 4.23 meters. So the question then, does that actually make it into the nest then? Well, remember our nest is 4 meters away, and it has a diameter of 30 centimeters. So therefore, that's 30 centimeters is 0.3 meters. So in other words, if the nest is centered at 4 meters, then the nest then would cover the range 3.85 meters to 4.15 meters. So that's the x range of the nest. 3.8, so that's a total length of 0.3 meters, 30 centimeters. I'm sorry, this should be meters over here. And so if the mouse landed somewhere in this range, it would end up in the nest. But we found that the mouse actually lands at a distance of 4.23 meters. So it misses the nest. So here's our nest then. And this position was 3.85. This position was 4.15. And this was 4 there. Well, the mouse actually lands somewhere right over here. Okay, so it misses the nest then.